Hey guys, Mr. Long Break here. Today we're going to pick back up where we left off last week with Q equals MC delta T. And we're really going to be focusing in on that Q variable today in a process called calorimetry. I'm not going to hold you accountable for that word, but that is the name of the process that we're going to go through today. And the biggest concept that you have to understand and get through is that Q equals Q. And what that means is however much energy is absorbed in a particular process or reaction is equal to however much energy is released in that process or reaction. And that's because of the law of conservation. Energy cannot be created or destroyed, just like matter can't be created or destroyed. So if a particular system absorbs a certain amount of energy, that's how much energy was released by the surroundings. So the Q of the system equals the negative Q of the surroundings. However much energy is absorbed by the system is equal to however much energy was released by the surroundings, or vice versa. Now this is called a calorimeter, and I just wanted to show you a picture of it. If you go into upper level chemistry, or if we had the chance to do labs in this unit in person, you would see an actual calorimeter and use one. And here is a much more simplistic version of that calorimeter. And here it's telling you, here's the Q of the water, and then the Q of the block. So it's telling you that the water is absorbing 761 joules of energy. Well, if the water is absorbing 761 joules of energy, then that means that the block must be releasing 761 joules of energy, because energy can't be created or destroyed. So however much energy is taken in by that water is equal to how much energy is released by the system. And in this case, that is that metal block there in the calorimeter. Okay, so now we are going to solve a calorimetry problem, and we are going to use the concept of Q equals negative Q, but on top of that, we need to know the equation from last week, Q equals MC delta T. So we're going to use both of those to solve this problem, and I will tell you this problem is exactly like your Schoology assignment. So if you can solve this problem, then you're going to be completely fine on the Schoology assignment once you get to that. It says you are given a metal and you're asked to determine the identity, and the way we're going to do that is by finding the specific heat of the metal. And so down here I'm going to say C of the metal, because remember C is specific heat, equals question mark, because that's what we're solving for. It says you place the metal in boiling water. And so right here I have a picture. I'm not the greatest artist, so just bear with me, but I have boiling water and we have that unknown metal in that boiling water, and that's just to heat the metal up. And we're going to heat it to a specific temperature of 100 degrees Celsius. Well, how do we know that? Well, that's the temperature that water boils at, and we should know that or remember that from the heating and cooling curve stuff that we covered at the beginning of the unit, and that will come in handy later in the problem. Then it says we transfer that metal to a calorimeter, and that calorimeter is full of 50 grams of water. And basically, when that metal is placed in that calorimeter, this is the data that is collected. And that is the data we're going to use to ultimately find the specific heat of the metal. Okay, so we know that Q equals MC delta T. And if I wanted to know the specific heat of the metal, then I would need to know the metal's Q, M, and delta T. Well, if I look up at the data table, the only thing that I know about the metal as of right now is its mass. I don't know its delta T, and I don't know its Q. Therefore, I can't just simply plug it into that equation, or at least not yet. And so what we're going to do first is we are going to find the Q of the water. I have the information to do that. So the Q of the water is going to equal the mass of the water, which is 50.0, times the specific heat of water, that's 4.18, times the delta T of water. And I'm going to find the delta T of water by subtracting these two numbers. And so when I do the final temperature minus the initial temperature, I get 7.70 degrees Celsius. That was the temperature change, or delta T, of the water. So once I have that, the Q of water is going to be equal to just multiplying those three together. So I'm going to do 7.70 times 4.18 times 50.0, and I get 1,609.3. Now I'm going to go ahead and round that to 3 sig figs, so I'm going to get 1,610 joules of energy. That is the Q of water. Now, some of you might be asking, well, why did we do that? That's not what the question's asking for. Well, that's the first step of finding the specific heat of the metal, and that is because of this concept. The Q of the water equals the negative Q of the metal. However much energy was absorbed by the water right here in this calorimeter was how much energy was ultimately released by that metal. Therefore, I know that the Q of water, 1,610, equals the Q of the metal, negative 1,610 joules. Well, now I have the Q of the metal. On top of that, I have the mass of the metal. And so the next thing that I need in my formula, I have Q, I have M, I need to find delta T. Well, how do I do that? Well, the delta T of water is going to be the final minus the initial. Okay, so what is the final temperature of the metal? Well, I know the final temperature from what happened in the calorimeter. The final temperature of the water is 26.20. Well, when things transfer heat or energy, they continue to do that until both of the substances are the same temperature. So because the final temperature of the water is 26.20, I know that that is also the final temperature of the metal, because they will continue to transfer energy until they are the same temperature. Okay, well now how about the initial temperature of the metal? Now the initial temperature of the metal is going to be found by using the concept of the boiling water. Water boils at 100 degrees Celsius. So if we place that metal in that boiling water for a certain duration of time, that means that it's going to reach that temperature eventually. So the initial temperature of this metal is 100.00 degrees Celsius. Now that we have the final and the initial temperature, we can solve for the delta T of the metal. And we do that by final temperature, which is 26.20 degrees Celsius, minus initial, which is 100.00 degrees Celsius. And when I do 26.2 minus 100, we get negative 73.80 degrees Celsius, and that negative sign will come back into play, so make sure you keep that there for the time being. So if we check back in on our Q equals MC delta T equation for our metal, we have the Q, we solved that in step 1 and 2, we just solved for delta T, and we have the mass of the metal that was given to us in our original data. So now we are ready to finally solve for that specific heat of the metal. So once again, I'm going to use the formula Q equals MC delta T. And unlike at the beginning of the problem, now we have all the necessary information. Q is negative 1,610 joules equals M, which is 30.0, times C, that's what we're solving for, so I'll leave that as C, times delta T, which is negative 73.80. Okay, so what I'm going to do is I'm going to take 1,610 and I'm going to divide it by 30, and I'm also going to divide it by 73.80. And when I do that, the negatives cancel out and make a positive, and I will get the specific heat by getting C by itself. And specific heat will equal 0. Rounded to 3 sig figs, because 3 sig figs is the least number of sig figs, 727 joules per gram degrees Celsius is the unit for that specific heat. And that's our final answer. And basically using that specific heat, you can identify what that metal or particular substance is. So you should have all the information that you need now to do the Schoology assignment. Like I said, it is exactly like this. So please refer back to this video. It will really help you in making sure that you score the best that you can on this particular assignment. As always, if you have questions, please let me know. You can reach out to me via Google Meet, Schoology, or email. I miss you all, and I'll talk to you soon.